We're going to start this section by talking about the sig trig functions and their definitions. So to begin with, let's say that I have some point out here represented by the ordered pair x, y, and I have a line that travels through that point. So if I have a line that goes through that point right there, maybe, I have a line that passes through that point. I know that that line rotated from the x-axis right there some value theta. So I have rotation, I've got a point. I also know that this point is some measurable distance away from the origin along this line. So this is a distance. We call this distance r. In order to calculate the distance here, we're going to use Pythagorean's theorem, which we need to have right triangles for and to be able to use Pythagorean's theorem. But real quick, let's remember that Pythagorean's theorem said if I have the base or one side of a triangle squared plus another side of a right triangle squared, that was going to be equal to the hypotenuse of my triangle squared. So let's keep that in mind as we draw this picture here. So this point xy, I'm going to drop an imaginary line straight down perpendicular to the x-axis, and you can see that I now have a right triangle. If I have a right triangle, I know that this vertical distance right here is going to be represented by the y value, and the horizontal distance of my triangle is going to be represented by the x value. So now if I want to try and fit all of this in other words, if I want to know what the distance or the measure of my hypotenuse is, it's going to be the side squared plus the other side squared equal to the hypotenuse squared. So to solve for the hypotenuse, or in other words, to solve for the variable r, I would take the square root of both sides, and I would be able to say that, well, if I want to look for the value r, I can do that by taking the square root of my x value plus the squared value of my y value, and that gives me r. So this right here, my x, y, r the hypotenuse, and theta all combine to give me and create the definitions that I need for my trig functions. So this right here is a list of all 6 of those functions. So let's go over this for just a second. If we let xy be a point other than the origin on the terminal side of an angle theta in standard position, in other words, here's my same figure. If this blue line started here on the x-axis and rotated up, okay, then it stops, then that means it's the terminal side. And I have some point on that line that is a distance r from the origin. Notice that if I'm talking about distance, or I want you to remember if I talk about distance, then the value of r will always be positive. Okay, so knowing all of that, we can look here at these 6 trig functions. This top row right here, made up of sine, cosine, and tangent, are the 3 most common trig functions we'll use. The second row, which would be the inverses of the first row, made up of cosecant, secant, and cotangent, are not quite so common, but we will need to know all 6 values of these trig functions. So the sine of theta is equal to the definition. If I wanted to know what the sine of theta was, I could find it by taking the ratio of the y value measure over the r measure. So it's y over r. Okay, so this would be y over r gives me the value of sine. If I talk about cosine, I'm looking at x over r. If I talk about tangent, I'm looking at y over x. And then these 3 are just the inverses, or the reciprocals, I mean. Notice how if I'm talking, so sine and cosecant go together, cosine and secant go together, and tangent and cotangent go together. So if I know what sine is, I can figure out what cosecant is by just flipping the fraction. Same goes for the second pair and for the third pair. Okay, so this right here you need to put to memory. You need to memorize it for the rest of the semester because it will be extremely, extremely important. So that's kind of our introduction of our trig functions.